Welcome to Knowledge Base. In this video, we are going to be looking at combined series and parallel resistance. The question here says, find the total resistance of the combination. When you have this kind of combination, where you have series and parallel combination all in a given system, to find the total resistance, you go through the following steps. The first thing you're going to do is to identify clusters of parallel resistances or clusters of series resistance and solve them separately. After resolving these clusters of parallel resistance or clusters of series resistance, the circuit or the system reduces to either a simple series combination or a simple parallel combination, and then you can finish up the solution at that simple combination. So in this particular problem, we are going to identify the clusters of the parallel resistances and solve them individually. How do we identify a parallel resistance? We identify a parallel resistance by looking at the direction of current flow and then identifying where there is a branch that splits the current into two or more branches, or there is a point where the current splits into two or more branches. Now let's look at this current I flowing in this direction. It flows through the 4 ohm resistor, and when it comes to this junction, it splits into two, which means that these 2 ohms and this 1 ohm are cluster of parallel resistance. Then the current continues in this form, and when it gets to this junction, it splits again into 3 branches, which means these 3 branches are another isolated or cluster of parallel resistance. So the first thing we are going to do is to resolve the parallel resistances or resolve the resistances from the right to the left. So we are going to start with this 3 set of parallel resistors and resolve and find their equivalent resistance. So firstly, let's resolve this parallel combination. Remember, in parallel combination, the inverse of the total resistance is equal to the sum of the inverse of the individual resistance. So this becomes 1 all over R, where R is the resistance of this 3 combination, and that is equals to 1 all over 3, the first resistance, plus 1 all over 5, the other one, and then plus 1 all over 5, which is the last resistance. This is the parallel combination. We are just going to take the LCM here. The LCM of 5, 3, 5, 5 is 15. So 1 over R is equals to LCM is 15. 15 divided by 3 is 5. 5 times 1 gives us 5. 15 divided by 5 is 3. 3 times 1 gives us 3. 15 divided by 5 is 3. 3 times 1 gives us this 3. So if we resolve this further, we have that 1 over R is equals to 5 plus 3 is 8 plus 3 is 11 all over 15. To obtain R, we simply invert this. If the arrow comes up, we're going to obtain R. So as we invert the left-hand side, we definitely invert the right-hand side as well. So that R is equals to 15 all over 11 ohms. So this is the total resistance of this set of parallel combination. Now that we've done with this, we look at this parallel combination again separately. 2 and 1 in parallel gives us 1 over R is equals to 1 over 2 plus 1 over 1. The LCM is 2. LCM of 2 and 1 is 2. 2 divided by 2 is 1. 2 divided by 2 is 1. And 1 times 1 is 1. 2 divided by 1 is 2. And 2 times 1 is 2. So that 2 plus 1 gives us 3 all over 2. And if we find R by inverting this, we also invert the other side, which is the right hand side, and that gives us R equals to 2 all over 3 ohms. Now we've resolved this and we resolved this. We now have a simple series combination of this and this resultant resistance here and this resultant resistance here, so that the circuit reduces to the 4 ohms. This is now going to be replaced with 2 over 3, while this is now being replaced with 15 over 11 ohms. So this is now a simple series combination. And when you have a simple series combination such as this, you simply add up each of them to give you the total resistance, so that Our R total is equals to 4 all over 1. We do over 1 because these are also fractions, so let's make everything fraction, plus 2 all over 3 plus 15 all over 11. In series combination, we don't take the inverse, so we sum them normally, just the arithmetic summation of the resistances. So our R total is equals to, if we take the LCM here, the LCM here will give us 33. So let's take it one after the other. 33 divided by 1 is 33 times 4 gives us 33 times 4 plus 33 into 3. 3 into 33 is 11. 11 times 2 gives us this. Then 33 divided by 11 is 3 plus 15 times 3. If we resolve the numerator, it gives us 33 times 4 is 132. 11 times 2 is 22. 15 times 3 is 45. By the time you add everything together at the numerator, it gives you 199 all over 33. So 199 divided by 33 in your calculator will give you a total resistance of 6.03 ohms. So this is the total resistance of the circuit we started analyzing. I hope you enjoyed this video. Thank you very much for watching. Please try this and put your answer in the comment section. What is the total resistance of this combination? See you in our next video. Bye.